Welcome to Bugged Out, the bite-sized podcast where we explore the art and science of functional verification and how to get the bugs out of the world's most complex chips. I'm your host, Harry Foster. Today, I'm joined by Vladislav Palfy, Director of Solutions Management at Siemens EDA. Vladislav recently authored a white paper titled Questa One Unified Coverage Solution, Transforming Verification Through Intelligence. We're going to dive into why coverage closure has become such a bottleneck, how Siemens' unified approach changes the game, and what it means for engineers and teams in practice. Vladislav, before we get into details, what first inspired you to focus on coverage closure as a critical area of verification?
Honestly, Harry, I was watching really talented engineers slowly lose their minds chasing that last 10% of coverage. And I think you're familiar with the scenario. 2 a.m. before a milestone, someone's trying to cross-reference 3 different spreadsheets and trying to figure out if 87% of code coverage and 92% of functional coverage actually means that they're safe to tape out. And, this usually involves copious amounts of caffeine and some creative language. And if we look at the data, it's pretty brutal. We have, I think, 3/4 of a project, is it, according to the study that you ran, that are running behind schedule.
Yeah.
And coverage closure has become one of the biggest bottlenecks. But what really got me is when I saw that most people are using the traditional approach, because let's face it, we were allowed to in the past, just throw more tests, more engineers, more compute, easy. But that's not scaling anymore for reasons that I'm sure we're going to get into a bit later. Right? So it's like trying to fill a swimming pool with a teaspoon. That just doesn't work.
Okay. In your paper, you point out that 75% of basic projects are missing schedule and that coverage closure is a big contributor. Why has this become such a persistent problem?
So first, there's design complexity that has absolutely exploded recently. So you're not just verifying logic anymore. People are verifying interactions between hardware, firmware, software, across multiple power domains, security boundaries, whole 9 yards, right? And it's more like a difference between debugging a bicycle and a Formula One car while it's racing. Right? So we've gone a long way. The second point would be that traditional methodology hasn't really evolved to match this complexity. I think I've mentioned this already, that teams are using the playbook from 10 years ago. Thousands of tests, manual analysis, cross your fingers and hope to hit corner cases. So what happens then is that initial progress looks great. You're climbing that coverage mountain, feeling good, and then you will hit a plateau. And that's the point when adding more tests just doesn't give any return. So the coverage barely budges, but your test suite keeps growing exponentially. And so that can be quite maddening. And the third reason is that verification engineers' time is increasingly fragmented. And when a coverage call gets discovered, it's usually very late in the project, and it doesn't just impact the schedule. It will force teams to have a painful choice between shipping on time or shipping something that actually works. And it's not just a technical challenge, it's really a symptom of a verification methodology that hasn't kept up with the modern semiconductor design. Breaking through this, I think we need an intelligent, integrated approach. Otherwise, we're just burning more electricity and hoping for the best.
All right, let's move on. You describe Questa One as taking a fundamentally different approach, moving away from brute force to intelligence. Could you outline how unified coverage differs from traditional methods?
Of course. So I would say that unified coverage is proactive and intelligent. There's actual planning involved as opposed to run more tests and hope for the best, because that's quite unpredictable and at times desperate. But here's the fundamental difference. Instead of blindly generating thousands of random tests and hoping some of them hit what you need, we actually analyze patterns in your existing test suite to understand what's been covered and what hasn't. So when your coverage does stall and you hit a plateau, instead of throwing more engineers and more compute power, the system will ask intelligent questions. Is the code actually reachable? Are the constraints blocking certain scenarios? What's the most efficient path to hit a corner case? The questions that a really experienced verification engineer would ask if they had infinite time and patience. And there's really 3 key pillars to the unified approach. First, it's unified planning. So we'll start with systematic verification. planning, and I can only recommend our VIQ test plan author there, because we can link requirements directly to coverage goals from the get-go. And you can plan for coverage challenges before they actually become problems and not discover them during the final verification phase when everybody's already stressed and time is running low. As a second point, I would mention that we can front load the coverage. And you have a lot of people who actually wait after the test bench is done to analyze coverage, which is kind of like waiting to buy beer once the party is already over. So I would say we enable meaningful coverage from day one by rigorous static analysis. So you can catch gaps early, and you will not be misled by incidental coverage from random testing. And as a third point, we have intelligent automation. So if you do hit a plateau, the solution will automatically analyze patterns and it will generate precisely targeted tests. So it's not just automation for the sake of automation, it's really intelligent collaboration between the engineer and the tools. And we've seen some pretty dramatic results. Coverage was achieved with 500 times fewer tests, and debug times probably slashed by a third, and regression time as well. But what's more important, this really transforms verification from this exhausting expeditions where you're never quite sure when you're done into a mapped, precise journey where every test has a purpose and can actually demonstrate completeness instead of just copy.
One of the key ideas is the unified coverage database. Can you explain how that helps teams work together more effectively, even across different verification engines and geographies?
Harry, I would say that UCDB, I like to call it the unsung hero of the whole solution. So think of it as a digital librarian with perfect memory and no patience for disorganization. It's not just storing data, it's orchestrating the entire verification journey. And I'll give you a real-world scenario that will probably sound familiar. You've got simulation runs happening in Taiwan, formal verification in Germany, because we like precise things, emulation in the US. So traditionally, you'd end up doing what every verification engineer has done before a milestone review. You'll stitch together a narrative from fragments of information that are laying around some spreadsheet. And when you cross-reference those, compare reports, try to figure out if your coverage numbers actually overlap or if there are gaps between them, you're basically doing archaeology, not engineering. You're digging through layers of data, trying to reconstruct what actually got verified. And UCDB changes this completely. It's able to seamlessly capture, unify all the data in a compressed binary format, and it will maintain your design hierarchy perfectly, handle code coverage, functional coverage, assertion, power, safety, you name it. And uniquely in the industry, we also integrate test plan coverage. So you can actually trace from a requirement through your test plan down to actual coverage results and back again. And what makes it powerful for distributed teams is the intelligent architecture that it has. It doesn't just dump anything into a folder and call it done. It really maintains coverage continuity and has adaptive merging across different source code revisions. And even if your design evolves, your teams can track this progress meaningfully. And when the standards body updates the spec, you can instantly see which scenarios are affected, which tests need updating, which coverage goal need adjusting. And the benefits you get from this collaboration are real. We have teams reporting about 20 to 25% faster closure times and about 100 fewer team hours per week. So that's real money you get back. But beyond the numbers, I also like to think it's a psychological relief of not having to manually correlate everything and be responsible for the job you did manually. You can actually ask intelligence questions, like show me where my code coverage is high, but assertion coverage is suspiciously low. We'll zoom in on that data. You can ask it which requirements are verified by multiple coverage types versus just one if you want extra confidence. So the questions you should be asking but never have time when you're running spreadsheets.
You also highlight the role of Questa One VIQ Coverage Analyzer and Visualizer. How do these tools complement each other when teams are trying to debug stubborn coverage holes?
This is where strategic thinking meets tactical execution, Harry. It's a two-stage approach to solving coverage mysteries. So if you think of Questa One VIQ Coverage Analyzer as your strategic command center, it's browser-based, it's revealing coverage patterns through heat maps, distribution graphs, all those different analytical visualizations that actually make sense. So if you're in your Monday team meeting, instead of everybody looking into spreadsheets, arguing about what the numbers mean, you can be looking at a shared dashboard that immediately shows you the top 20 design units where focused effort will yield the biggest improvements. So when an engineer in, let's say, San Jose discovers an important coverage pattern, they can instantly share their customized dashboard with their teammates in Munich or Bangalore. And all of these dashboards will automatically update as new data flows in. So it's collaborative in a way that actually helps instead of just creating more meetings. So visual alarm sim, on the other hand, is your tactical weapon. So this is where you dive deep to understand the why behind each coverage hole. So instead of static analysis, where you're just staring at numbers, it offers dynamic debug sessions where you can run to breakpoints, step through code, watch coverage scored, updated in real time, and so on. So I look at it a bit like having extra vision into your design's behavior. You're not just guessing, you're seeing exactly what's going on. And if you look at how this could be a workflow, so coverage analyzer might reveal a pattern of our uncovered branches in a specific module. And then with a few clicks, you can transition to visualizer, where the post-processing debug capabilities will let you correlate coverage data with design behavior and waveforms. You're not just seeing what wasn't covered, you're seeing exactly why it wasn't covered. And was it a constraint issue? Was it a test bench gap? Actually unreachable code. Now you know instead of guessing. And if you take this dual approach, you can address the full spectrum of coverage closure challenges. Coverage analyzer will help the team understand where to focus their efforts, and visual will provide the insight needed to actually solve the problems.
Many verification engineers talk about hitting the dreaded coverage plateau. You add more tests, but the percentage doesn't move. How does Questa 1 help break through this wall?
So I've mentioned the coverage mountain before, so let's keep to that analogy, shall we? So the coverage plateau you mentioned is every verification engineer's nightmare. You're making good progress, and then you're suddenly stuck at 85%, and adding more tests is like pushing a rope uphill. The needle barely moves, your regression suite keeps growing, you're consuming compute power, and you don't really get anywhere, so it can be quite maddening. And this plateau happens because, as we said already, the traditional constraint random testing is essentially throwing darts in the dark. You can hit the easy targets, but then you're left with the stubborn corner cases, and you begin to stall. So Questa 1 will break through this wall with 3 different intelligence strategies. First of all, Questa 1 Sync Coverage Acceleration, or QCX, how we like to call it. It is really quite a breakthrough technology that will stop the madness of just throwing more resources at the problem, and instead it will analyze the coverage landscape, and it's able to plot optimal routes to your goals. So think of it like an expert navigator. It sees the patterns that others miss, it identifies uncovered scenarios, and it can generate precisely targeted tests. And we've had some quite remarkable results, I must say. If you have a massive SoC infrastructure that used to be a 7-day effort, QCX complete this in under an hour. And I really mean that. For peripheral IP verification that once required 8,000 tests, QCX is able to chart a precise course using just slightly over 100 tests. And it will cut your journey from hours to minutes. So we have cases where we're seeing up to 100 times faster time to coverage closure in real-world scenarios. Secondly, we suggest people to use Questa 1 increased coverage. So this will tackle a different aspect of the plateau. It will ask the question, is this actually a genuine verification gap? Or is it just unreachable code that no amount of testing will ever touch? So you can really transform your coverage score from, let's say, 80%, sometimes to over 90%, as the tool systematically identified unreachable cold spots. And each finding is mathematical proof. So it's not really up to debate anymore. It's really based on evidence. And thirdly, we have intelligent analysis. So when your coverage does plateau, we have ranking algorithms that will evaluate the effectiveness of your tests on multiple factors, how much they contribute to coverage, what their historical performance is, what the runtime is, and the automated analysis will suggest specific strategies for breaking through. whether it's targeted test generation or by modification of resistant tests. And the key insight here is that the plateau isn't insurmountable. It just requires some intelligence instead of brute force. We stop throwing more darts and just start aiming better.
And finally, if we look ahead 5 years, what do you see as the next evolution of coverage closure? Will AI play an even bigger role?
It's playing a big role already. We are quite far ahead with it. But in 5 years out, Harry, I see that AI and machine learning will be deeply woven into every aspect of coverage closure. But my take is that it will augment human intelligence and not replace it. Now, let's be honest, we're not trying to put verification engineers out of work. We're trying to stop them from working on the weekends. And we're already seeing this with QCX, ML-driven test generation. But I can see this evolving into truly predictive coverage planning. Imagine your verification environment, analyzing your design on one day and telling you, based on similar designs and historical data, here are the 5 areas that will be your biggest coverage challenges, and here's the optimal verification strategy for each. Right, so we're not talking reactive, we found a problem, but truly predictive. This is going to be a problem, and here's how to address it now. And of course, cross-project learning is going to become huge. Right now, each project essentially starts from scratch. I mean, there's IP reuse, but you're essentially starting from scratch, and it's kind of absurd if you think about it. But if your coverage tools can learn from thousands of previous projects that you did or open ones across the industry, that's going to build institutional knowledge into the tools rather than having every team rediscover the same problems. And I'm also excited about real-time coverage-driven test generation. So not just analyzing after the fact, here's what we covered, but during simulation. The system can watch coverage in real time, dynamically adjust test generation to target the gaps that were discovered. It should be like having an expert verification engineer looking over your shoulder, but it just doesn't get tired and need more coffee, which I think is going to be good. But what's most important, AI will handle the mechanical aspects. Pattern matching, optimization, that tedious correlation of data, which should free up verification engineers to focus on what they do best. Understanding design intent, identifying critical scenarios, making judgment calls about risk and quality. So it should give engineers a superpower so they can focus on interesting problems instead of drowning in spreadsheets.
Vladislav, thank you so much for joining me. This has been a great conversation. For our listeners, if you'd like to dive deeper, be sure to download Vladislav's white paper, Questa 1 Unified Coverage Solution, Transforming Verification Through Intelligence. The link is in the show notes. Thanks for tuning in to Bugged Out. You can catch this and all the episodes on the Verification Academy. Until next time, keep verifying and keep smashing those bugs.